All right, for my last video of the day, I'm going to look at page 7, example number 4. And once again, I'm going to look at using both the sides and the diagonals. In this case, this particular proof is easier with the diagonals. We'll see in a minute. But we can use the side lengths. So we can find the length of any of these sides from P to Q. It goes over 4 up 5. And same thing for SR, goes over 4 up 5. So distance is 4 squared plus 5 squared under my root. That gives me a square root of 41. From S to P, or from R to Q, it's going over 4 down 5. But because when you square a negative, it turns positive, that gives us exactly the same thing for our final length. So all 4 of these are the square root of 41. So the fact that the opposite sides, like SP and RQ, are congruent means that this is a parallelogram. And the fact that all 4 of them are congruent means that it's a rhombus. That's the definition of a rhombus. We can also look at the slopes. If I get the slope of PQ, I see it goes up 5 over 4. Same thing for SR. So these two sides are parallel. They have the same slope. That's the slope of positive 5 over 4. For SP, it's going down 5 over 4. Same thing for RQ, down 5 over 4. That's the slope of negative 5 over 4, and these two are the same. So these two are also parallel. These little arrow type notations, those indicate parallel if these match up. So this is parallel, and this is congruent. All right, so the opposite sides are parallel. That's the definition of a parallelogram. It is a parallelogram. But the consecutive sides, these are not perpendicular. Even though that might kind of sort of look like a right angle, it's not, because these are not opposite reciprocals. They are opposite, but for this to be a reciprocal, this would have to be positive 5/4 and negative 4/5. So because they're not perpendicular, this is not a rectangle. So we can say it's a rectangle. It's a parallelogram, it's a rhombus, it is not a rectangle. So the most specific thing we can say about it is that it's a rhombus. All right, like I said, this one's actually easier with diagonals, so let's switch over to that. It's easier with diagonals because when you draw the diagonals, one of them's horizontal and one of them's vertical. So that means we don't really have to calculate much of anything at all. The midpoint of these two diagonals, for SQ, I only have to find the x value. I just average the two x values, 9 and 1. So 1 plus 9 over 2 is 5. The y value is going to be the same as the y value of both Q and S, so 6. So 5, 6, right here. For PR, I don't have to worry about the x value because both of these have an x value of 5, so that one will have to as well. And I just take the y values, 1 plus 11 divided by 2, which gives me 6. So I get the same point. These two intersect at the midpoint of each, so they bisect each other. Since they bisect each other, this is a parallelogram. Again, the length, I don't have to use distance formula. I could just use subtraction. From S to Q is 9 minus 1, which is 8. From P to R is 11 minus 1, which is 10. These are not the same number, so the diagonals are not congruent, and it's not a rectangle. The slopes, well, SQ is just horizontal, and PR is vertical. Horizontal and vertical lines are always perpendicular. So since these diagonals are perpendicular, this is a rhombus. So I know that PQRS is a rhombus. I didn't have to calculate anything except a couple of quick averages to check the midpoint.